Okay, so here's problem number 2 from your worksheet, which is actually number 11. The directions said to find all exact values of the function. And by looking at this polynomial with a degree of 4, I know that we're going to end up with 4 of them. When you see all, that means real and imaginary. When you see exact, that means no decimal values that are gross and ugly and irrational. If you're dealing with something that is like that, you better have a radical answer for it, something like that. Okay, so if you're looking at a polynomial like this, it's a fourth degree, there's 5 terms, there's no way I know how to factor that thing, and you probably don't either. So your only other option is to go to your calculator. So I grab my calculator. I've already entered my equation in my y1. Notice I turned off plot 1. We did some scatter plot stuff. Turn off plot 1 because sometimes it interferes and won't let you graph because plot 1 is highlighted. And then I'm going to do a zoom 6 just to reset the window so I know it's a normal looking window. So there's my function coming in. The shape makes sense because it is a fourth degree polynomial. It looks kind of like a parabola. And it looks like it's hitting the function at 2. So I'm going to try a 0 of 2. Now we should be able to tell if it works or not because of what kind of remainder that we get when we do our synthetic division. So here goes into our function. I've got 1, -2, 6, -32, and 40. Make sure that you fill in missing zeros if you've got exponents missing. Okay, so synthetic division, 1 drops down, multiply and add, multiply, add, multiply, add, multiply, add. And we were good with the 2 because I got that remainder of 0. Now the function that I'm left with is a cubic. It's something like x cubed plus 6x minus 20. And again, I don't know how to factor that, and again, you probably don't either. So we need to look back at the graph and see if there's a 0 that we're missing. It doesn't look like it hits anywhere else, but remember when you see a bounce like that, or what you guys call a touch and turn, that means we have a multiplicity. So not only is 2 one of our zeros, it's actually 2 of our zeros. So I'm going to divide it out again into the previous result. So 2 is going in. I have to admit this is the second time I've done this because I added incorrectly. I put 0 plus 2 is 0 and couldn't figure out what my mistake was. So let's fix it. 2 times 2 is 4. That's 10, 20, and 0. Okay, so another remainder of 0. So it looks like we're in good shape with having the multiplicity of 2. Okay, so what are we left with? I have 1. My degree has been decreased down to a square, plus 2x, plus 10. If this is something you can factor, then please do so. But because we didn't see them on the graph, chances are they're not going to factor out. So I need to figure out how to solve x squared plus 2x plus 10 to find the missing zeros. You could use completing the square on this. That wouldn't be a bad problem, although most of you don't like completing the square, so I'm going to do the quadratic formula. So x equals negative b plus or minus square root of b squared minus 4 times a times c all over 2a, and then just do some simplifying. So negative 2 plus or minus 4 minus 40 is negative 36 all over 2. That's got a nice square root, so negative 2 plus or minus 6i over 2, and then I can divide them both by 2. So I get negative 1 plus or minus 3i. So that gives me my 4 zeros. So to sum up, our zeros are the 2 that we found from the graph, 2 and 2, which you only have to list once, it's fine, and then our remaining 2 that we found using our quadratic formula, negative 1 plus or minus 3i.